pre-algebra, we are wrapping up our unit on proportions, similar polygons. Anyone know what similar polygons are? Or have a guess, considering our entire unit has been on proportions? Similar polygons are polygons, which are essentially shapes, right? I'll put in parentheses shapes here, with proportional sides. Proportional sides. So it's kind of like a scale drawing of a shape, okay? Polygons, shapes with proportional sides. So of course, we're going to be setting up some proportions with this, right? And one thing to note, I don't think we get into it on this objective, but just so you know, even though the side lengths of similar polygons are proportional, the angles are equal, okay? Anyone know how many degrees a triangle has? Every triangle has exactly the same number of degrees. It is not 90. Hmm. 180, right? Every triangle will always have exactly 180 degrees, no matter how big or how small, okay? So just note that with proportional figures, you'll hear about this more in geometry. But even though the sides are proportional, the angles are still equal. The angle measures are not affected, okay? So anyway, getting down here, here are two similar figures, okay? Figure A and figure B. And I want you to note that, you know, in figure A and figure B, even though figure B is clearly larger, I've labeled the long side of each figure and the short side of each figure. Because if you remember with inverse proportions, and really all proportions, those units matter, how they're lined up, right? We never wanted our units to line up diagonally. If you think with inverse proportions, right? It was more of A over more of B, right? Less of A, less of B. Same thing here. Only instead of more and less, we have long and short, right? So if I'm setting up this proportion, and I put the long of A as the numerator of my first fraction, what are my two options for the denominator of this first fraction? Remembering that our units need to line up either vertically or horizontally. If I start with the long of A as the numerator of this first fraction, what could I put as the denominator? Short of A. Okay? And I can do that because my A's are lined up vertically, right? Long of A over short of A. Okay? And then now, what would the numerator of my second fraction have to be? I don't have any more options now. What is long of B? Very good. Right? Because I got those long and long lined up horizontally. Okay? And then the last option here, short of B. So you can see again here about how our units line up vertically, A, B, or horizontally. Long, long, short, short. Okay? Method 2, starting with the long of A again, Josie gave us short of A as what could go underneath it. What's the other option? Gregory?
Long of B.
Long of B. Right? Because I've set up my units long over long. And then what does the numerator of my second fraction have to be? Short of A. And the only other thing left here is short of B. Again, notice, nothing that is a similar unit, none of my like units are lined up diagonally. They're all either vertical or horizontal. As long as you do that, you will be fine. And then, how do you solve a proportion? What's been our go-to method that we've used time and time again here?
Cross product.
Cross products. Okay. Questions on this? It's very similar to what we've done, only it's with shapes rather than, word problems or things like that. All right. So let us go down to the bottom here. And it says, ooh, is that how yours looks too?
No.
Ooh. That's how yours looks?
Yeah.
You've got them all messed up?
Well, mine's right here.
Yeah. It's supposed to be
and then like my COs are like at the bottom.
That is weird.
oh, you got your whole thing.
Yeah, I got.
I wonder if it's
Yeah. Oh, and I have like my COs like at the bottom.
at the bottom. Some must have got messed up with the spacing. I will reprint this for you.
No.
You want it to be all messed up?
Yeah, it looks funny.
Okay. I'm going to reprint it for you because I don't think you know what you want.
No. Just don't.
Already did. It's already sent. Okay. So looking at the bottom of the page here, it says solve for the unknown side of the figure. Show your work. We're going to set this up both ways here. Okay. So give me one way to set this proportion up to solve for, and we'll call it n. Okay. Give me one proportion that we could use here to set this up. And let's start. Actually, before we set it up, this is our short side. This is our long side. We can see the end side is longer, right, than the short side. And on the other rectangle here, this would be the short side because 15 is less than 24. So there's our short and our long, if you want to call this shape A, shape B, right? You don't have to write these things in. You kind of can just see it, but if you need it, then they're helpful. So how do you want to set this up first? Give me a potential first fraction here that we could use. For the first one. Yes? 10 over 15. So Anthony's going with short A over short B, right? Lining up those short sides vertically. So short A over short B would be 10 over 15. And then our second fraction would be long A over long B, right? Short A over short B equals long A over long B. And that would be the long of A is 10 and the long of B is 24. Right? Give me another way to set this up. If we start with that 10 again, the short of A, what else could we use for the denominator of that first fraction? If we start with short of A, we've already done short A over short B. What's the other option? Short A over here was the short A over long A equals short B over long B. Here we're starting with short A. What's our other option? Got this. Here we line up our A's vertically, right? And our B's vertically. So in the second option, we're going to line up our shorts vertically and our longs vertically, right? So short A over short B. Oh, that's what we did. Hold on. Sorry, I had that backwards. I gave you the answer. Short A over short B is what this first one is. Long A over long B. Hold on. That deserves a... There we go. Okay. Short A over short B is our first one. So our second one is going to be short A over long A equals short B over long B, right? Short A over long A, that's going to be 10 over N. And then short of B over long of B is 15 over 24. Okay? Now, tell me, Why is that okay? To set this up two different ways. How mathematically does this still work out to get the same solution for n? Yeah. Good. Yes, because cross products is the same, right? Cross products, we are multiplying 10 by 24, dividing by 15. We're doing the same thing here. 10 by 24 divided by 15. So because cross products is the same mathematically, it doesn't matter which way you set this up. Right? And ultimately, what do you get?
16.
16. Do you have a second on that?
Yep.
That's good. Right? Go ahead and set that second one up yourself. This time, maybe you don't use short and long, but you use like top and side or top and left, right? All it depends on is the position of the side. Okay, you don't have to use short and long. I mean, you can see, top and top, side and side. You can use that. But go ahead and set up a proportion. Match up those corresponding sides. If you're not sure how to start, just pick a number. 12. Okay. That's the top of shape A, right? Where do I go from there? Line up your units vertically or horizontally, just not diagonally. Someone who's feeling bold and confident today, who would like to share what they set up? Jolie?
N over 12, and then 25 over 15.
Okay. Josie set up n over 12 equals 25 over 15. That works, right? Because she went side of A over top of A equals side of B over top of B. Right? A over A, B over B. Anyone set up a different one? Yeah.
12 over 15, and then N over 25.
12 over 15, n over 25, top of A over top of B, side of A over side of B. Perfect. And mathematically, can we see how this is going to be the same thing, right? Cross products in both cases, 12 times 25 divide by 15. Any others that you set up? There are several more you could do, just different variations of all of these things here. But anybody set up a different one? Reading, your hand was up. Did you have the same one as me up? Okay. Anybody else? No? There are others. Okay. But ultimately, what do you end up with here? What is the value? Yeah. 20. N equals 20. Questions on any of this? Okay, let's look at the backside. A couple different things going on here. More shapes to work with here. Again, you are setting up the proportion. I need to see the proportion when I check your homework in tomorrow, so work has got to be shown here. Set up the proportion. Solve for the variable. You got two triangles, two parallelograms. Down here, your x is just this section here, right? So you can't really use long and short necessarily. You might, but you can see kind of which sides correspond here. Two triangles here. Here's where long and short might become very handy because those triangles are not the same position, right? Which side, we'll call this short, which side in the other shape corresponds with our variable, with our question mark? If the question mark is the short side of shape A, what's the short side of shape B? The 35, right? It's the shortest side. We can see that there. Okay. What side would the 54 correspond with in the second shape? The 63. They're both the longest sides. And then if you want to use this 48 is like a medium,
I don't know.
or don't use it all, right? Do you have to use that one? No. Okay? But if the shapes are rotated, you really got to pay attention to long and short, top, bottom, things like that, because that position matters. Position matters there. Okay? Then I think there's some word problems down the bottom. Oh, 2 more shapes here to solve for. And then last Christmas, I built a life-size statue of myself to give my wife as a present. She thought it was creepy, so I built a second one that was 2/5 as big as the first one, thinking that it would only be 2/5 as creepy. Turns out it was just the same amount of creepy. If the original statue was 72 inches, how tall is the second one? Okay, so kind of a proportion, rates, ratios, all kind of combined in here. And then time for review, you can mow a lawn in 90 minutes. How many lawns can you mow in 3 hours? And a garden of roses, violets, and tulips, 800 flowers, and is the ratio of 17 to 13 to 10. How many of each type of flower is there? What type of proportion is this? Direct, partitive, or inverse? You can mow a lawn in 90 minutes. How many lawns can you mow in 3 hours? What type of proportion is that? Direct proportion, partitive proportion, or inverse proportion? Remember, the difference is, for a direct proportion, as one value goes up, so does another. Or as one value goes down, so does another. In inverse proportion, as one value goes up, another one goes down. Right? So what's happening here? You can mow a lawn in 90 minutes. How many lawns can you mow in 3 hours? Are 2 things going up, or is one going up and one going down? Is it direct or inverse? Think about it. You can mow a lawn in 90 minutes. If you increase the amount of time you spend mowing lawns, are you going to mow more lawns or less lawns? More, right? You spend more time doing something, you'll get more accomplished. Okay, so you can apply that to homework. More time doing homework, you'll get more homework done, right? A direct proportion. Okay, what type of proportion is this? A garden of roses, violets, and tulips is 800 flowers in the ratio of 17 to 13 to 10. Is that direct, partitive, or inverse? You are taking a whole and dividing it into parts. That is a partitive proportion. Partitive proportion, right? So if you need to look back, know which objectives these are, PO34 can help you with that one, direct proportions. CO35 can help you with that one, partitive proportions. Work needs to be shown for credit on the homework. Any questions, concerns, compliments, congratulations, criticisms? I think I missed comments. Anything you got? Very well. All right. Homework for tomorrow. That's my math.